Good morning, everyone. Myself Satvik, studying in GM University. So these are my teammates, Kiran, Sanket, and Gagan. So we are presenting a project on house price prediction using linear regression and decision tree. So in this project, we compare two machine learning models to predict house prices and evaluate their performance based on different metrics. So before going into our project, the first process is data processing. So in this process, we train our models. So here first we have to prepare a data set. So before going into our project, we take it from Scikit-Learn data sets where we copy this code and prepare a data sets where we use Boston housing data sets which contain information about houses in Boston. So the variables which we have used in it is crime. It's per capita crime rate by town. Then ZN, it's land zoned for lots over 25,000 square feet. Next is index, which is a non-retail business acre per town. Next is CHAS, it's a Charles River dummy variable. NOx, it's a nitric oxide concentration. Then RM, it's the average number of room per dwelling. Age, it's the proportional of owner occupied unit built prior to 1940. Then this, it's a weighted distance to 5 Boston employment centers where it's the index of accessibility to radial highway. Then tax is a full value property tax rate per dollar, $10,000, sorry. And prior tax, it's a pupil teacher ratio by town. Then B, it's a BK in the ratio of blacks by town. Last stat, it's a lower status of the population. Then MEV, it's a medium value of owner occupied by home in $1,000. So the steps which we use in the data processing is loading the data sets. So first we load the data from a CSV file. Since it's a raw data, we have to clean the structure and use it properly by Python and Pandas. So here are so many data sets where we need to purify the fake data sets and uh, use it by the next one. So the next process is handling the missing values. So here we checked for any missing values. Fortunately, the data set was clean, so we didn't need to fill or remove any data. So the third one is feature selection. So in this process, our data set contains 13 features that influence house pricing. So here we select them all, but laterly the feature is important to analyze, which helps us to refine our model. So the fourth process is splitting the data. To train and test our model, we split the data into 80% training and 20% testing using to train, test and split function from Scikit-Learn. So the second process is transition the model training. So now in this data, our data set is ready and we need to move to the core of our project, training two models, linear regression and decision tree regression. So this process will be explained by my teammate Gagan.
Thank you, Satvik. Handling file path and loading data. Once we pre-processed the data set, to next step was to load it into our program. Since our data set was stored in a CSV file, we used to the Pandas library to read it. We also ensured that the file path we was correctly handled to avoid errors. Common file path issues and fix. While working with file paths, we faced a common issue with Windows paths causing a Unicode errors due to the backslashes. To fix this, we used either raw string formatting or a double slashes. Implementing a linear regression and decision tree, we trained two models, linear regression and decision tree regression, to predict house prices. Code output and model comparison. What After training, we evaluated the models using the mean squared errors MSE and the mean absolute error MAE. Transition to the next speaker. Now that we have to our model evaluation, the next step is to visualize the prediction and compare with the model performed better. The next.
Thank you, Gagan. Now here we got MSME. It's mean absolute and mean square error. Uh, Now I will explain how we will evaluate this process. And now here you can see the output. We got simultaneously the linear regression prediction and decision prediction trees. I mean graphs. You can see the most points which are near to the diagonal red line, which shows that it is predicted more accurately. The more these points are which are scattered from the away from red line, which indicates that it's not predicted and it is not sufficient to conclude as a pattern or an output for an prediction. Look, I will explain what is now. I will explain what is squared error. It is the most important thing to evaluate which is better for conclude that decision tree or a linear regression for this data set of an Houston to predict an house varying price. Uh, Now we will look what is a MSE. MSME is an average square difference between an actual price predicted price, and absolute error is an ME, which is absolute difference between actual price and prediction value. Uh, I will explain you what it means. Uh, it's like an example. Look, you have an Zomato app. You have ordered something food. It will take 30 minutes. Predicted value. It will take 30 minutes, and it will predicted 30 minutes, and it was got delivered to you in 40 minutes. The total difference between 30 and uh, uh, which is predicted 30 and the delivered is 40. The error difference between and these 30 and 40 is 10. This is an error which is this is an error. When we square this error, we will get a squared error, and absolute error is nothing but that is 10, 40 minus 10. Uh, this how what mean an MSC and MA in a real world examples. Now we will evaluate collecting all these data and comparing which is predicted more accurately and which is scattered from an graph and which is nearby the red line. Thus how we will conclude our graph. The We use MA for interpretation and big data errors, and also to get an attention and to evaluate. Uh, in Here we in code part we have an x and y axis, which is actual. In graph section we have actual house price and predicted price, which is closely aligned to the red dot, which is closely aligned to the red dots, which indicates that performance is well, and which is away or which is scattered from a red dot line, it is not good, which will help for a real time prediction like household production, and we can further we can improve for an exam score detection. If it is a bad model, the scatter points are inaccurate away from the red light. Linear regression versus decision tree. Linear regression is a simple thing which is used to uh, work well in a linear data. Decision which splits data and decide which is accurate, which handles the patterns, which matches the pattern of a decision tree. Regression might underfit the data complexes and decision tree overfit it. Real time examples, as we are going through it. It is a household prediction. Basically, it is a US based data set. Look, At output, we got a regression ME and regression MA, mean absolute error. If MSC, I mean mean squared error is an larger than an mean absolute error, it means our model is a larger outlier in an prediction errors. If the MSC is ME closer, the model contains more error, which is more consistent, which is scattered. All data set has something like error. Uh, Now we done with an 20% of data set. Thus, we got a winner as a regression, linear regression, because we have linear regression as MSME decision tree as 27, which is greater than an linear regression. Thus, we conclude that this decision tree decision tree squared error is a highest. Thus, the winner is for a 20% of an test data. Thus, we conclude decision tree as a better choice. Now we will go through it a complete data set. Now we will go to files and we will take complete data set. Complete data set. This is an for a test data set. Now we will close this tab. Now we change the path. Look, we have simultaneously the linear regression and decision tree functions, which will done simultaneously. We no need to waste time for it. It will take some time because the data is too much. Now, look at here. You can see the linear regression, which has more points and some are scattered. You can see the more numbers of data are scattered. You can see less number of data are scattered away from the red line. You can see this graph, linear regression and decision tree graph. Now here you can see for a decision tree. For a large set of data set, uh, we have decision tree, because decision tree is most efficient and which has less scattered points away from it away from the diagonal align line. We can conclude from this picture also, and or these evaluation process like MSC and mean squared error and uh, mean absolute error. We will get different values for a test data, and when we implement at a large scale, we got different thing. At first, we got an linear regression is a better choice for a small set of data set. At a large scale, we get an decision tree prediction which analyze the pattern which is close to it and gets an output which is more accurate for it. This is this is a code. We use modules like a NumPy, Pandas, and Matplot for plotting these graphs, as you saw, and Skylar for an importing the regression and decision tree simultaneously, and also Scikit-Learn matrices for an mean squared error and mean absolute error, which is very essential part. As you know, now I explained how it is most important thing to conclude that which is a better algorithm. Conclude that for an given data set to work on a project. Now, at a small set, we concluded at a linear regression. At small scale, large scale, we got an decision tree. Thus, we conclude that this is our project, and further you will get more detail regarding conclusion how to get done by my teammate Sanket.
Thank you, Kiran. Now that we have the evaluation result, we can confidently state which model prepared better and why. After evaluating both models using mean squared error (MSE) and mean absolute error (MAE, here here are the results. From these values, we have that linear regression has significantly lower MSE and MAE compared to the decision tree. This means that linear regression made more accurate predictions. Lower MSE and MAE means linear regression performed better. Decision tree had higher errors, meaning it overfitted or struggled with the data pattern. To understand why, let's compare the characteristics of both models. Linear regression, it uses simple equations to model the data. When we move to the decision tree, it splits the data into decision rules. And the linear regression, when the data follows a linear pattern, is best. And is decision tree is when the data has complex and non-linear relations. And linear regression is simple, fast, and interpretable and generalized well. And the decision trees can capture patterns and interaction in data. Since our data set appears to follow a more linear trend, linear regression performed better. The decision tree likely overfitted to small variation in the training data, leading to a higher errors in a prediction. If the dataset had more complex patterns, decision tree might have been better. In this case, linear regression was the best choice because the data followed a linear trend. Based on a evaluation, linear regression is the better model for the dataset due to its lower error and ability to generalize well. Thank you.
ತೆಗೀಲೆ ನೀನು ಅದು ಮೀಟಿಂಗ್. So before we wrap up, we would like to thank ma'am and appreciate everyone for their time and participation. Thank you all for joining, and we thank and look forward for our next session. Thank you, everyone.